E squared. So E is like 2.17, which is like 2. So like what's 1 over 2 squared? 1 over 4. So this is like a negative number between 0 and 1. Does that make sense, you guys? And you should be like, I don't know exactly, I have no idea exactly what it is, but I know it's a fraction, because it's like it's 1 over a number, and then there's a negative in front. Does that make sense, you guys? Okay? So, and that's for more down here. But getting these two things, you got 2 points. Now, is the speed increasing at time 3? How do you determine if it, bless you, if the speed is increasing or decreasing?
Acceleration is the same sign.
Yes, and there's no pronouns there. Did you see that, you guys? The acceleration is the same sign as the velocity. So if you look what they did, in their explanation, we'll get to these in a second. Speed is increasing since, bam, bam. You see that? And that was it. Velocity less than 0, acceleration less than 0. That means negative velocity, negative acceleration. And you're done. Does that make sense, you guys? Great, just very concise, not writing a haiku, not writing a paragraph. That's what you need to see. Speed is increasing because velocity negative, acceleration negative. So, you just told me, Estella, why that acceleration was negative, yes? Because it's like negative fraction. Right? Right. How do you determine if this thing is positive or negative? What would you do? Here's the velocity. That's what I'm asking. Yeah, exactly. Oh. So I want to know how they determined so easily that this was negative without a calculator. What do we do? Because this is weird numbers. Do we just quit? David, give it a shot.
Well, you know that like
It sounds like you're not quitting. Okay.
you know that e to the negative second power is a fraction, so it's smaller. Well, we know that it's smaller than 1.
Yeah. Does that make sense, you guys? So it's negative 1 plus like, I don't know, 0.5 or so. It's a fraction. You know what I'm saying? And like they're not asking you like, when is this thing less than 7? You know what I'm saying? It's not asking you, it's like, when is this thing negative? That's all it's asking. So, okay, how do you compare the number negative 1 with e to the negative 2? And that's what they expect you to compare, Jackie, without a calculator. Okay? This is a fraction compared to negative 1. So this is also going to be negative. Does that make sense, Joanna? Nice. Okay. So, how do you figure out when a particle and then so that was 1 point. Just 1 point for the this line right here got you 1 point. Now C was another 2-pointer. How do you figure out when a particle changes direction? What are you thinking, Wayman? What's going through your mind when you see particle changing direction? Yeah, it's a great place to check. When the derivative changes sign. And a good place to start is when derivative equals 0. Does that make sense, you guys? So that's what we did. So just doing that, you know what I'm saying? Well, I guess you had to get the point. But. So if you set this equal to 0, 0 equals negative 1 plus e to the 1 minus t. And then moving that negative 1 to the other side, you get this. 1 equals e to the 1 minus t. Now, I'm supposed to solve this without a calculator, intersection point. You know what I'm saying? I can do that. Set this side on y1. Set this on y2. Find your intersection point. Great. I'll get my time. But how do you solve this? Amina. The only way an exponent raised to something can equal 1 is if that exponent equals 0. Does that make sense, you guys? It didn't ask for when is 7 equal to e to the 1. Who knows? I don't know. I have no clue. It asked when is it. So the only time this can happen is when t is 1, because 1 minus 1 is 0.
Could you just like show the work of solving it with like taking the natural log both sides?
Sure.
And that would like.
So then, like, well, like what did you get at the end then? So you got
just t plus 1.
So your natural log. So you got natural log of 1 equals natural log of e. Oh yeah, sure. Then this would be. So then this thing is done. This is 1. So 1 minus t equals 0. Great. Did you guys hear that?
So is that just like remove the justification part?
So
would you have to put that
so
in?
So see this. If you just set this like that, this would be fine. See there's no like justification for your algebra here, you know what I'm saying? That would be great. That would be perfectly correct math and they'd accept it. Reasoning, if they see this and this is showing like you reasoned your way for that to be equal. You know what I'm saying? And as long as they see that, not just magically nothing t equals 1, you know what I'm saying? They see that, then you'll get the point. You know what I'm saying? Or your work's great. But then the justification is for the sign again. You know what I'm saying? Like, because, okay, that's where it equals 0, but don't forget, just because something equals 0, it could, like, stop for an instant but keep on going right. You know what I'm saying? You can go, this is it, this is it. Do you know what I'm saying, you guys? I never change direction. It's a candidate. It's the only places where you can change direction, where the velocity is, you know, undefined, which doesn't really happen when you're talking about velocity, or equal to 0, because then you have that turning around. So great place to start. Before we get into the reasoning, let me ask you this. Could you guys solve for me when 0 is equal to 1 minus t in your groups? Different problem completely. If you were solving this, you're working your way through it, and you somehow had to solve by hand, when is 0 equal to 1 minus t? What time would you tell me? Let me know. Without a calculator. Without a calculator. What if this was 0 equals e to the 1 minus t, and you're somehow like supposed to tell me the time that occurs? It doesn't. Does that make sense? Great call. Some people can say infinity, but don't forget the limits equals 0, and limits talk about approaching. You know what I'm saying? There's no function value that you can plug in for t to make this equal to 0. Okay? So great, just having that understanding. So when would this change direction? Never. Because this is never equal to that. It would be kind of a side problem. Okay, cool. So then, you know, doing our same reasoning here, how could we figure out when this velocity thing is positive or negative? We just solve for it equals 0 at 1. How do we figure out when it's positive or negative? What can I do? Plug in what?
Solve for the points around.
Which one? Pick one.
0.9 and 1.
Without a calculator, what would you do? With 0.9 would be perfect with a calculator, but without, what would be a good one to check that? If it's at 1 is where it changes. 2 and 0? Sure, yeah, check like the next integers. Well, let's see if that would help. Negative 1 at 0, at t equals 0. Let's see here. We got negative 1 plus e to the 1. Why? It's 2 something. Does that make sense, you guys? So that at t equals 1, velocity is positive. Because it's just a little bit, I don't know, again, it's like whatever, but it's a little bigger. Okay, let's check t equals 2. Is that going to be positive or negative? Why is it negative, Jesse? What do you think? At t equals 2, why is that going to be negative? Plug a 2 in for t, and what do you get in that exponent? Negative 1. What are we doing with that negative 1? We're flipping it. All of a sudden we have a fraction, a positive fraction, we're adding to negative 1. Which one's bigger? Yeah. Velocity is negative. And since we have a change in the sign in the velocity when it equals 0, and it equals 0, you have a place where it changes direction. Does that make sense, you guys? Okay, good. All right, that's it for today.